So, hello friends. This is the third part of the series on Analytics Assistant app. In the first two parts, I covered using custom GPT to connect to data warehouse on AWS and Azure MySQL, including in voice mode. Now, in this video, we will cover three things. First, connecting to the same data warehouse on AWS and Azure, but via an external LLM app deployed on my public website, and summarizing, merging, processing data on file sizes of 1 million to 10 million records. Second, the basic architecture that I'm using, and the third, some cost considerations. So this is a setup very similar to what I'm using for a client currently supporting data engineering and some campaign operation tasks. So let's jump right into it. So this is the AWS prototype data warehouse schema with a bunch of table. We'll be working with a bank table with and a transaction table. Let's go to the app which is deployed on my website at exec.com. It's deployed on the open internet on a public website. So it's on the access control section. I'll be demoing the OpenAI version. I also have the Claude and the Google Gemini version. We also have the option of doing an on-premise of a self-hosted one with the open source version. Currently, this is the OpenAI version. So let's look at the tables in the warehouse. So these are all the tables in the warehouse. There are a bunch of temporary tables. Let me request it to drop. Can you drop all the temp tables? So it's able to figure out what I mean by the temp tables. Yeah, it is. And let look at 5 sample records in the bank customer base of 1 million customers. So it has all the demographics and campaign kind of information. How many records? So yeah, it's got 1 million records. Now let's look at 5 sample records in the transaction table. So it's pretty standard format, customer ID, transaction code, amount, date, and how many records? So 10 million records. So now I'm asking it to create a summary and put it into a new file, and the summary will create around 10-11 new variables: cash, retail, separate, average transaction values, and a whole bunch of things. Everything is in natural language, and this is the API call which it has passed. Let's extract the query which is passed. So this is the backend query, creating all these variable averages, average transaction values. Absolutely perfect. And let's see now. So it has now gone ahead and created those, shared the logic of that it has used, and how many records are there. So there are 300,000 records, which is basically 30% of my base is active, remaining is inactive. Now I am asking it to merge it back with the bank table and create a new merged table. And so let's look at the variables in the newly created merge table. So it has all the existing tables, variables, and as well as the new variables have been added. Now I am asking it to create a sales activity profile, so which will have averages and average transaction values by cash and retail. So here it is, active customer, cash active, cash and retail, separate average transaction values. Similarly, I am asking it to create the same profile by the housing variable. Earlier it was. So let's look at the query itself in the backend. So this is the query in the backend, which is absolutely perfect. And all the variables it has computed. And now I'm asking it to compile all the profiles it has created into one single profile report. So a single profile report. So response, responder, non-responder, housing, and by education. Okay, now let's look at how we can do this, or rather how I have been doing this. There are numerous ways of doing this. So I am sharing the one which is specific for my use case, but I do believe it has broader applicability for many use cases. So we start with the user and the user interface. So any user interface, it can be through a custom GPT. It can be a front end built with tools like Flowise, Vector Shift, or any of the other numerous LLM platforms. Now, each platform or a tooling has its own pros, cons, pricing, and considerations. Uh, Alternatively, it can be built completely custom built using React, JavaScript, PHP, especially if you want to build authentication and link ups to your company SSO logins and access to the data warehouses there. So that depends on again the use case. Uh, I have used so in my previous video I had shown doing it with custom GPT. In this video I have shown it with a UI built which is built with Flowise AI. It's a rapid uh, LLM tool for rapid deployment, wonderful to use and huge capabilities. Now, another key aspect with the LLM app platform that you are using or the things that it needs to do is the LLM model choice. Now, you have a whole range of options there, and there are trade-offs between pricing, speed, response quality, and security privacy. So there is no single best answer there. In some cases, the premium pricing of models like a GPT 4o, Claude Sonnet, or even a Claude Opus might be okay. Now, in other scenarios, you might find that the free limits provided by Google Gemini are sufficient, right? In some case, it might make sense to host an open source model on your own server, especially where there is very high usage and or privacy and security considerations are there, which will be an on-prem solution, right? So the best approach will depend on the specific use case, and it needs to be it needs to be a very case to case assessment, because another angle is that you can use multiple models in mixture depending on the kind of use case. So difficult things, expensive model will do. Simpler thing, the cheaper model will do, right? Now, one of the critical functions of the LLM in this scenario is to take the user's response and the context, figure out what they are talking about, even if there are spelling mistakes or if the user inputs are haphazard or fuzzy, as you can see in my use case or the demo which I did, and then create the right API call, or rather the parameters to be passed for the API call. That's what all that it does. It creates the SQL query, which is actually the parameter. Now, after that, the tool itself, it makes the API call. Now, that's pretty much standard HTTP fetch request. LLM model is not doing anything now, right? Now, that's a pure IT side of it. It's pretty much a standard HTTP fetch request that the IT world has been doing for decades, and that call can be made by whichever tool, whichever language you are using. Now, specifically in my setup, the query now goes to a fast API server. That's the next part of it. Now, since I am comfortable in the Python environment, I found fast API to be a easy and a quick way to deploy a processing server. So that's what I tend to do for my use cases now. I understand the Python code also a little more easier. However, this is the only option. There are many others. You can use a standard REST APIs, but I find them to be a bit tougher, honestly. In any case, all the coding is done by GPT based on my instruction, but it does take some iteration. Sometimes you need to check the code yourself, where GPT gets stuck to get it working properly in a live environment. A lot of testing is required. Now, I have kept this processing server as an API endpoint and separate from the main system. I can directly, potentially, I could have connected the LLM app Flowise directly to a database server. Also, there are many ways to do it. So I have kept this processing server as an API endpoint and separate from the main system. While you could potentially connect the LLM app directly to the data warehouse without this middle hop, I choose to keep it separately for reusability, right? Now, this allows me to connect the middle processing layer to any UI app. The client might want to do it via custom GPT or Flowise or some other way, and the backend database could be anything. So this makes it very reusable. And all that I need to do is change the DB connection and point to the new API endpoint URL. So that's the way I've gone about it. The code itself is a short, simple Python code. GPT coded it. All it does, it takes the incoming query, establishes a connection with the database, sends the query to the database, receives the response back, and then sends the response back to the whoever is making the API front end, that is making the API call. For my response, this one I use a pipe delimited format, but it can be any format: CSV, JSON, or even an object can be passed along, like file, image, video file. Again, the IT world has been doing this for decades. Then the database, it can be Azure. In my case, I have connected it to Azure and AWS. It can be anything. It receives the query, processes it, and then sends back the response. And the fast API server catches the response, then hands it over back to the UI front end. Uh, Back to that LLM app. Now the LLM app or your front end, then you know that it receives the LLM input, it formats. It could be receiving that in pipe delimited format, as in my case. Then it has to format the input appropriately. So in my case, it comes in a, like I said, pipe delimited format, and then whichever format the user has requested for, or whatever is the appropriate for that response, the LLM sort of serves it that way. Now here is one important point in this whole framework and thing. The top part, that is the newer part, right? That is the whole breakthrough part, right? Where the LLM model now is able to convert a natural language in a natural language into a SQL query or an API parameter. That's a huge big part, and there are a bunch of considerations there. Accuracy of the query. How do you make sure that the query is accurate? You can use a simple LLM model, or you can use a agentic framework, with a supervisor worker setup, or any many other setups are possible. Now, the rest of the remaining framework that you see there, that all that framework are just API calls essentially. It is the HTTP fetch request. That is something the IT world has been doing for ages. The entire internet backbone is built on this two-way flow of information through API call. Passing through text, data, objects. Everything. All the apps that we use, the desktop and the web app, is based on, that's the framework. Large proportion it is on the REST API framework, I believe. Okay, so now let's talk about the costing. The total costing can vary very widely, from a few dollars per month to a couple of hundreds to thousands to millions, depending on the use case and the scale. So costing depends on your specific architecture and the use case. I won't be able to do justice to a overall pricing costing video in a few minute segment. Instead, I will focus on costing for the prototype like this and cover a few related angles. So for the LLM app platform, the LLM app builder, I am using Flowise, so which by itself is open source, so it is free, but you still need to host it. So for this prototype, I hosted it on a render, costing me around $7 per month. Now the Flowise server acts as a messenger, and it provides the user interface. So taking user input, reaching out to the LLM model for processing before showing the result to the user. So this setup is less intensive, but if you have to handle hundreds or tens of thousands of messages per minute, obviously the $7 server won't be sufficient. Now regarding the LLM model cost for this prototype, no, that's a very varying kind of area, and many angles are there. So in this particular case, just to give you some idea, it's only a single data point, but at least there is some info. So I ran a whole bunch of queries for this demo, and in preparation for this, in creating synthetic data set by merging, summarizing, and creating cross tabs and all. I was working exclusively with the 1 million customer data set and the 10 million transaction data set, creating that synthetic data set and, doing all sorts of things. So this effort lasted around 10 hours on, a few days back, and that resulted in approximately 470 API requests. Now, most of them were SQL queries, SQL query generated by OpenAI. I was using GPT 3.5. The total token usage was about 1.9 million, with 1.8 million being input tokens and around 52,000 being output tokens. And the cost was around USD $1. So USD $1 for a day of work over spanning over 10 hours, 475 around 470 queries, which was, I'll say, fairly intensive. Now, this was with GPT 3.5. Now, had I used GPT 4 there, it would have been exactly 10 times more. It would have been exactly $10, since the GPT 4 cost is 10x, right? Now, the high input token count, if you see 1.98 million input token count, that is due to the for the message completion, for each message, the entire history is being sent out with every query. Now, which can be optimized. uh, output tokens average just around 110 per query, representing the that will be the reasonable size for a SQL query generated or the cross tab results. Now this was a non-optimized setup, so I was not bothering too much about optimizing anything. I was just using it as is. So the costs were higher, but with proper optimization, they can be reduced significantly. Now it's important to note that the costs are only for the SQL queries and the context inputs, right? The LLM model itself isn't ingesting significant data. All the processing is happening at the database end. So that's how this prototype has been set up. If the model had to ingest all the data and then run the data on the queries on the ingested data, the input token cost would multiply exponentially, possibly increasing cost by 100 times or more. Now let's talk about this angle about this concept about ingestion of the full data set. Now ingestion of the full raw data set isn't always required, but in some cases like building a model with OpenAI's code interpreter, the modeling data set would need to be ingested. The code interpreter of OpenAI, it does an excellent job of creating a machine learning model, but requires ingesting the whole modeling dataset, full dataset or the random dataset, whatever we are feeding it. Now, if the entire dataset is ingested via an external API, external app like this one, the API cost can skyrocket, right? Potentially increasing by 100 times or more. I have tried it with the tiniest of datasets, and I can tell you the costs are huge. Now, for comparison, as a different this thing, using OpenAI's GPT-4o plus and uploading the data in the chat window there, uh, it has got a fixed cost of $20 per month. So the API cost don't apply. It can create model very efficiently, but for very large data sets or even largest data set, it starts to crash. So to summarize, in scenarios where full dataset ingestion is not required, like in the current demo, as well as some of my existing use cases, processing is done separately. The LLM only passes the SQL queries or Python pandas statement, and the processing is handled at the database or the Python server end. Now, in a scenario requiring full data ingestion, such as model building, then we would need to split the workflow into multiple modules. Only the necessary and the smallest amount of data would be ingested directly by, say, OpenAI, while the remaining data processing, model build, or any kind of transformation, everything else will happen either on the database server or the Python server end. So this kind of optimization will depend on the specific use case. That's one of the next use cases that I'm working on, hoping to share it soon. Now let's look at the cost for the FastAPI server. So that's not much. It's just an API endpoint. It's an API endpoint. This can be deployed on any server of your choice. Currently, I have deployed it again on Render, where I'm paying $7 per month. It only charged when the server is up. Now, in a small use case like the current one, the Python server, in this kind of a use case, the Python server is acting only as a messenger. It takes only the queries from the app, passes it to the database, gets the response back, and sends the response to the LLM app. Therefore, it's a lower load server is sufficient because it's only doing a messengering. But again, depends on what kind of messengering. If you have 100 of queries coming in per minute versus handful of queries per minute, it's a different thing. But it's not currently doing any processing. However, in a different scenario, which again I am currently working on, some processing will happen at the database end, MySQL end, and some at the Python server end. Now, why is this required? Now, this is necessary to run some data cleaning, transformation, statistical procedure, and model builds using Python, which is not possible at the MySQL end. So, in this case, the Python server, it is not just acting as a messenger and just endpoint. It will be processing. It will be doing a bunch of processing. So in this scenario, the data will be downloaded into the Python server, ingested into a data frame, and processed there. So for this kind of scenario, higher a higher capacity processing server would be required, depending on the database size and latencies and so on. The last piece is the database server cost. So that's up to each organizations own uh, related to its own setups and all. So I am on a free tier for this prototype. I am on a free tier for Azure and AWS, but there is still some a small couple of dollars a month, slightly higher for Azure. Cost depends on the cost. Ultimately, the cost will depend on the configuration of virtual machine, database server, IP gateways, and all. And for AWS Azure, it's one big maze, so to say. Now, I am using in AWS, I am using the RDS MySQL, and for on Azure, I am using the MySQL flexible server. Now, in both cases, I have a virtual machine setup, virtual machine in Azure and EC2 for AWS. The database itself is standalone, and the EC2 and virtual VM instance are actually not required for the database, but it is required for PHP So I am using PHP as a UI over a database for database admin, and in case I want to run queries directly on the database. So the cost of these VMs can vary based on that your specific use case and what else you need to install there based on the requirement. Hello friends, I hope you found the video useful. In the next set of videos, I am creating detailed tutorials and step-by-step guides to help you replicate these prototypes. This will include codes, various tips, my learnings, and how to best leverage on GPTs to get all this done efficiently and quickly. After that, I will be covering areas like Python processing, including building a machine learning model, further table operation, efficient data download, security with API keys, selective access control, and other stuff. See you soon.